Hello guys, welcome to our new video tutorial series. And in my previous video I had explained about the non-preemptive and preemptive scheduling and how it's worked by the processes, how priority scheduling works in non-preemptive scheduling. And in this video I will explain with a example with the non-preemptive scheduling, non-preemptive priority scheduling, how it's work. So we have the five processes. P1 has 0 arrival time, then P2 2, 4, 6, 8, and this is the completion time, and this is the priority given by these processes. So first of all we are creating a Gantt chart construction. So for example we have in the non-preemptive programming, non-preemptive scheduling, it cannot uh, interrupt by the other processes. So in that case we have arrival time 0, which will move in the ready queue. Okay, so we have a ready queue which has P1, and P1 starts executing because the priority is 3 right now. It will take like 0 to 10 seconds. Okay, so if we at the time 0, it will arrive at 0 and it will take like 10 seconds to execute. Okay, so right now we have a ready queue P1 which is in the ready queue. Then we have the P2 which comes at, oh, so as you see that we have a P1 which has arrived at 0 right now, so we just execute that with the 10 seconds. And then luckily we have the P2 with the priority of 1, so it also need to be executed as soon as possible, which will take 5 seconds. So at 10 it will come and it will take like 5 seconds, so 15 it will be removed from the ready queue. Then we have a ready queue, we have the P3. Also it has the highest priority, so it will take to the scheduling, and it will take like 8 seconds, so it will take like 23, and it will also remove from the queue. Then we have the P4 which has priority 4, which comes at arrival time 6. It also has the highest priority, like we already executed 3 priority 1 2, so the remaining we have 5 and 4, so it has highest priority. So we just include that in the ready queue and we will execute it. It will take 4 seconds, which is 27. And then at the end we have the P5 which will take 6 seconds. So we have the, it will execute at 33. So in this example, we have very simple scenario, like the priority is already been, you know, uh, the given with the arrival time. So it doesn't has any difficult part in that. So if the P2 has priority 5, so in that case we will switch to search for the next highest priority, for example P3. So we will execute P3 first, but this is a very good example. So it will execute as like simple non-preemptive priority scheduling. So this is how we construct the Gantt chart. As you see that, first of all, identify the process with the highest priority. At time 0, P has arrived, it has the highest priority among all. Then available processes, so it's run the PT at 10:10, PT finish, then P2 has arrived, it also has the highest priority 1. Then again P3 at time 15, P3, P2 finish, P3 is the next with the highest priority. Then time 23, P3 finish, P4 is the next highest priority. So it is a very good example. Gantt chart construction is order to process. So this is our Gantt chart. this is the total time it takes. So completion time and average waiting time. So completion time of each process, P1 takes like 10 seconds, PT completes at 15, P3 completes at 23, P4 completes at 27, P5 completes at 33. So what is the turnaround time? Turnaround time is completion time minus arrival time. So P1 take 10 seconds and it's 0, it will complete in 10 seconds. P2 comes at 15 and it will take 2 seconds to complete. So the turnaround time is 13. P3 complete at 23 and it will take like 4 seconds. The turnaround time is 19. And then P4 complete at 27, it will take 6 seconds and turnaround time is 21. Again P5 has 33 and it takes like how much time? Arrival time is 8, so it takes 25. So this is a very good example. And then there's a waiting time, turnaround time minus bus time. Turnaround time is 10, at already calculated, and then bus time 0, 8, 11, 17, 19. So what is the average waiting time? Average waiting time is our waiting time divided by number of processes. So it is like 11 seconds if it is in seconds. So average waiting time for each process is 11 seconds. So this is a diagram explanation, like in initial state time 0, P has arrived, P starts running and will complete until time 10. At time 10, P1 finish and then we will check from the ready queue which process has the highest priority. So we already have the P2 has the highest priority, so we finishes P2, then again P3 has a highest priority. So this is how it works in orderly position. So the average waiting time is 11 units in seconds, indicates that time each process spends waiting for it starts running is 11, the average waiting time. So this is the summarizing of the Gantt chart. P1 will work from 0 to 10 second, P2 10 to 15, P3 15 to 23, P4 23 to 27, P5 27 to 33. It basically, the example is so good, so it works in a orderly condition. Otherwise it will be uh, a different scenario. So P1 takes 10 seconds, P2 runs from the time 10 to 10, it will take 5 seconds to complete, but in total it takes 15 seconds. P3 15 to 23, P4 23 to 27, and P5 27 to 23. So this is how the we make the Gantt chart. It's very simple. You just need to first you create the table like that, then we will take the uh, one line, and then first come first with the priority, the arrival time. The first process always execute with the 10 seconds, and then the next process in the ready queue, and which process has highest priority will execute second, then third with the highest priority, then fourth, and then fifth. So I hope you understand this very good, because it's very good example, and hope you will uh, like and share my videos. Thank you for watching. Stay tuned for the better informative videos.